This is the second of the problems that we have with the sine rule. Sometimes the triangle that we're asked to draw could look different. So there are two possible ways of drawing the triangle with the dimensions that we've been given. So let's have a look at an example. This is from page 24 of the book. It's question 2a, objective 2.3. We are given some information about a triangle. First of all, we're given that a side of this triangle, which we'll say is this one, is 12 centimetres. Then we're also given an angle in the triangle. So we are told that this angle here is 40 degrees. Now, I've done a dotted line for that one because we're not told the length of that side. All we're told is that the angle between these two sides here, this one and this one, all we're told is that that angle is 40 degrees. So, the bottom side that runs along, change it to purple, this line here, could be any length, provided it's in that direction and makes an angle of 40 degrees. Now this is where it gets a little tricky, because we are then told that one of the other sides, the side that's going to run between this end point here and the purple line, is 8 centimetres. And you might think, well, let's just draw a line in that's 8 centimetres. But I want to try and illustrate the fact that there are actually two possible angles that will work. So if we take a circle of radius 8 centimetres and put it on, the circle has radius 8 centimetres, so from the blue dot here in the middle to the edge of the circle is 8 centimetres. You should see therefore that there's actually two possible triangles that we can draw. One of them goes down here, with that being 8 centimetres, and one of them goes down here, with that being 8 centimetres. So let's move our circle up again, and you should see then that there's two possible triangles. Put some colour into it. There's a yellow one, which is here, like that, and then there's a bigger one all the way around the edge, like that. So there are two possible options, and our task is to find out what they are. What we can start by doing, just going back a few steps, is we can use the sine rule in the normal way with one of our triangles. So let's draw it as a 12 centimetre side, a 40 degree angle, and draw it like the big triangle, what that one looks like, so 8 centimetres. And we can find this missing angle down here, which the book has called X, so let's label it X, using the sine rule. So our sine rule's down here, make this a bit bigger. You see, you've got to learn this for the exam, but we've got it on the board. So, put the numbers in the same. First of all, label, so A, B and C. Same for the sides. What you should find is, once you work that through and put it into the sine rule, you should find that you get sine of x is 0.964. At this point, you can quite easily use the normal method, press shift and sin, or sine, and answer, or put in 0.964, and you should get an angle of 74.6 degrees. But we know from before that there's actually two possible triangles. There's one where the angle x is this one that I'm going to colour in orange here, but there's another one where there's a much bigger angle for x. So there's two possible triangles and we've only found one possible angle. How do we find the other one? Well, we'll go back to GCSE, although some people won't have seen this. If we look at the sine graph, we find that it's a nice shape like this. This point here is 180. So this here is 0.964, and we're going to do this in detail in later chapters. And this is our 74.6 degree angle that we found. However, we also notice that the graph is equal to 0.964 at this point here. And the way we work that out is we do 180 take away 74.6. Later chapters will deal with this in detail, but what that does tell us is that another possible angle for x is 105.4 degrees. Just to summarise, what you need to know is that there are two possible angles whenever we get sine x equals something like 74.6, and you need to be able to know or remember that we can find the other one by doing 180 take away 74.6.